ATC procedures and radio telephony. What does comes to your mind? How it is important with respect to the drone operations? Okay, the name itself tells ATC procedures, where we are not flying or we are not doing any kind of activity with respect to ATC. So there could be a question in your mind that what is this ATC procedure and radio telephony? Why this is required? Any thought around it? Yeah, yeah. Please answer. Please answer.
I think it's because since we are flying aircrafts, even they are small and they are not going to potentially be interacting with regular air traffic, it's still important to know if we ever have to operate within that same scope.
Okay. Yeah, Nishan.
So ATC is basically a centralized body which helps in managing all the aviation activities. Hence, we have to consider them and ask them before taking any action.
Okay. Kapil, your thought?
Sir, according to drone perspective, I think following the drone rules uh, which are laid. So following that ATC procedures and these communications had to be followed.
Okay.
So
So
I was just
basically,
wondering, sorry to butt in.
yeah,
I
yeah,
was just
yeah. Go ahead.
wondering, as a drone operator of a particular drone, would are we assigned any radio call sign, or how do we identify ourselves to the ATC
I'll
over
come to
the?
that. I'll come to that. I'll come to that. You are on right track actually, Gautam, but there is little bit deviation into it. Not really a radio sign like what we talk about from the RTR perspective or from the ham radio perspective kind of thing. There is a different thing here. Okay, I'll tell you what it is because we are still not equipped for RTR actually, okay, like what we have in CPL or SPL kind of thing or PPL kind of thing. Okay, but why do we require to speak to ATC? Do you think that during our operations, any given point in time, we would be required to speak to ATC? In what scenario? Take a guess.
When we're operating near an airport,
Okay,
In the yellow zone, inner yellow zone.
correct. So whenever you are flying a drone in yellow zone, you are supposed to interact with ATC. Okay, because that is a controlled airspace. Whenever you have a approval to fly or you have a requirement and you have taken necessary approval to fly in a yellow zone, it could be inner yellow zone or in a outer yellow zone about 200 feet. Correct?
Yes, that's it. Yes.
So inner yellow zone and outer yellow zone about 200 feet. Okay, that is the space where you need to communicate with ATC about your operations. Okay, so at given point in time, BGC feels that you may be required. This is just the beginning, but in future, whenever you have the BBLS rules available, that point in time, you may also required, or maybe similar to ATC, there might be a some different body who will be actually monitoring your drone operations also, similar to ATC. So with that respective, that the DGC has made these ATC procedures and radio telephony to be learned in this module also. This is a small module, not much detail into it, but if you want to communicate about your operations in yellow zone, how do you communicate? In that case, also in red zone also. Because even though you are red zone, the permission is given by the central government, your operations will be monitored by the ATC. Okay, so that arrow also you talk to. How do you, what is what that is? Now, with respect to the radio telephony, okay, there is a new guidelines has come in February 2025. Okay. Currently, the radio telephony is being monitored by WPC, that is Wireless Planning and Commission. They are basically currently monitoring, but in future, maybe down the line, I think after June or July, it will be completely under the DPC-A. Because there are certifications and licensing activities are also going to be coming for the drone pilots. Just a minute.
Hello.
Okay, so sorry for that interruption. So that is what it is. So at any given point in time, the ATC is required to be communicated whenever you are doing any operation in yellow zone or in a red zone. Okay, so now let's see what is ATC. So understanding first the ATC operations. Communication with ATC plays an important role as we enter the manned aircraft airspace. The yellow zone is always a manned airspace and ecosystem. ATC should be informed of ARPA's operation prior to the commissioning of the operation. That means, for example, you are going to fly a drone at 10 a.m. That doesn't mean that you have to call ATC at 10 a.m. You have to call at least 2 hours prior, i- intimate them about your operations. That point in time, also you need to give some information so they are ready and they acknowledge it, so that on time your operations can be performed properly. It is important to follow the ATC procedure in order to avoid interruption to the manned aircraft traffic. Because since we are flying the drone in a yellow zone, which is manned aircraft zone or manned aircraft traffics would be there, we have to make sure that we follow the ATC procedure properly. Each RPA operator must be in two-way communication with ATC. Okay, so you have to be in a two-way communication. Since you are not a licensed operator, okay, you are not a licensed operator of communication. Okay, that is something called as RTR. Okay, you are not operator, so you are not eligible to use those kind of devices. Okay, but you have to communicate over the communication channel, whatever the ATC prescribed, maybe on a landline. RPA pilot should be aware of the airspace and restrictions impacted in it while operating an RPA. That means in whatever that yellow zone, wherever you are flying, for whatever purpose you are flying, you should be in complete control. You should be knowing that airspace very well, the restrictions imparted time to time again in that particular zone or that particular airspace. Okay. So radio telephony basics. RT provides the means by which pilot and the ground personnel communicates with each other. The information and instruction transmitters are of vital importance in a safe and expeditious operation of aircraft, personnel involved in operations and people on ground. So whenever you are communicating with ATC, you have to be very very clear. You should be very sound. You should be very polite, and you should be having all information at hand. You can't that point in time start discovering what is what and what is not. Okay, so you should be ready with your information. You should be ready with your operations. You should be ready with all the requirement what is there with respect to that activity in itself. Okay, so because the time is very precious at that point in, and the information what you are communicating to ATC also is very very important. Okay, so what is radio telephony techniques? The radio telephony or radio communication must be carried out in a following manners. It can be using RT phonetics, that is alphabet as well as numerics, RT phraseology, it could be Morse code, and latitude longitude informations. And you need to know the RT frequency spectrum in which what we are communicating to each other. Okay, so you should know about the RT frequency spectrum. So overall, if you see this radio telephony topic, is as of now we are not using it much. Okay, I would say very very negligible. For example, even I have not used any given point in time this information or this module. Okay, this will come more effectively if I have to fly, because I have been flying most of the time the agriculture drones, or most of the time I have flown drones for power line transmission monitoring kind of. So most of the time these locations are always in a green zone. I never had flown a drone in a yellow zone. But in case of yellow zone, it is very rare case. Okay, Okay, until unless you are into some kind of those kind of activity or those kind of requirement comes to you, then have to communicate with these procedures. Okay, so let's see what is the RT phonetics first. So RT phonetics is nothing but it's a phraseology where we use terms like A for alpha. Like you lot of time we communicate even when we are talking to a mobile or we are communicating to somebody and we're talking and giving some instruction. A lot of time some information or some word needs to be spelled out properly. So we use A for apple, B for bat, C for cat, and all the thing, D for Delhi, N for Nagpur and all this. But in a aviation world, there is a very fixed telephony words are there. For A for we always say alpha, B for Bravo, C for Charlie, D for Delta, E for Echo. There we can't see D for Delhi, okay, or there we can't say N for Nagpur or M for Mumbai kind of word. We have to say these phraseology, these telephony words only. A for alpha, B for Bravo, C for Charlie, D for Delta, E for Echo. Like that, you have to go up to Z. And numerically also like 1, 2, 3, 4, 5, 6. A proper word, you have the number 1, number 2, number 3. Okay, so Echo 4, Echo 5, like that. We should communicate the alphabets as well as numericals properly to the ATC. So this is what we have to communicate. Like for example, I want to tell the ATC that I am flying a drone at Nasik location. So Nasik word he may not be able to interpret properly. So he may ask me to spell it out, or maybe I have to spell in. Okay, so Nasik I would spell it as N for November, A for Alpha, S for Sierra, I for India, K for Kilo. Like that I will be communicating to ATC about the word Nasik. Okay, or even suppose I want to talk about some number over there. Let's say at 10 a.m. or something like so 10 I have to communicate 10 a.m. or 1000 hours, okay, like that, or 1100 hours, like that we need to communicate to ATC. Okay, again the same thing, alpha, bravo, charlie. So up to Z you need to know what is clearly word. Okay, lot of time people make mistake like N for Nagpur they say, or people like M for Mumbai say, or H for any Hyderabad. People are not familiar with this kind of words. Okay, but when we are talking with ATC we should use only these words. Okay, these are globally used words. Okay, or the phonetics what we call. Okay, again there is a Morse code, but this is not more important as of now because we are not communicating anything in Morse code to ATC. But in case you need to communicate, you should know how to Morse code. To learn Morse code, it takes almost more than a 1 month or 2 months. You should know like this is a language of dot and dashes. Okay, so the A is represented by dot and dash. B is represented by dash dot dot dot. C is represented by dash dot dash dot. So to learn here, the Morse code is not like how we learn the ABCD. Okay, so it's not that we start the letter word A and say, okay, A is that and dot, B is dash dot dot dot. That way, you will never learn Morse code. To learn the Morse code, there is a specific pattern to learn Morse code. Okay, so for example, in Morse code to learn, we will start with the word called E first. So there is a single Morse code. Okay, for E is a only dot, or whether if you see T. Okay, these are the single word Morse code. So we'll start with word E, then T, then double dots like I, or double dashes, okay, like M. Okay, these are the words we'll start first learning. The simpler words, easier to remember. These words we'll be practicing. So initially we will be using these simple words, simple letters, two letters like I, T, A, M, P, M. Okay, at, those kind of two letter words. Then three letters words will form. Like this will perform. And again, to learn a Morse code individually, you cannot learn a Morse code. You need to have a partner. Okay, so when you learn with a partner, and there are some apps also available which you can download on your mobile and you can practice it over the 1 month practice you do it, you can easily learn the Morse code. So normally in radio telephony exam, when you have to convert the Morse code words or the letters or the sentences, you need to convert with the speed of almost 30 words per minute. Okay, so that is what is the speed is required to be people to learn about it. But as of now, don't worry. From a drone perspective operations, we are not using Morse code. This is I am just giving you an example because I had done the ham radio licensing and all that things, so that's why I'm aware. Also, I am actually preparing myself for the RTR licenses also. So from that perspective, I am aware of these things. Okay, this is more or less when the pilot goes for training for their CPL licenses. That point in time, there is a separate subject called RTR. Okay, which is again a very difficult subject to pass for the students. They have to learn all this phraseology as well as the Morse code and all. So with respect to the drone operations, wherever we are conducting our drone operations, we should know the latitude and longitude of that location. To begin with a simple question, do you know what is the latitude and longitude of Mumbai? Any idea? What is the latitude and longitude of Mumbai? We have been using Google Maps, right, on mobile, so we should be knowing, right? Or a lot of time we search in Google also about the locations and also. Are you aware what is the latitude and longitude of Mumbai? No. Latitude is nothing but these are the horizontal lines on the Earth sphere, where it starts from the equator being as a 0, and subsequently it will be 10, 20, 30, 40. It goes up to the North Pole as 90 degrees. Similarly, longitude lines are vertical lines on your globe or the Earth sphere. Okay, it starts from the prime meridian, which starts from the Greenwich. Okay, from the Greenwich on the left side is your America or location. On the right side is the Africa and the India location. So we are always what we say ahead. Okay, ahead of longitude lines. So longitude lines, whenever it is 12 over here, we can always say plus 530 into that. So 12 plus 5 is 1750. So whenever we are having a 530 in Mumbai, that is the time. In London, it will be the sun will be on the noon side or on the head of the your side of you. That is how it is. Yes, Nishan.
Sir, can you please repeat this?
So what do you want to understand? Latitude or longitude?
Both actually, I got a little confused.
So latitude basically it starts from the center of the Earth, center. I would say the equator part, okay, which is crosses the 0 degree on the Earth, and from there it goes up to the North Pole or goes downwards towards the South Pole. Every latitude like 5 degree, 10 degree, and it goes up to the North Pole as 90 degree. Okay, so these are all parallel lines to your equator. Okay, whereas longitude lines are vertical lines to your prime meridian or Greenwich line. Okay, from where actually your time is calculated. Okay, so your Greenwich mean time is always plus or minus on either side of it. From our side, it is always plus. So, for example, in Greenwich time, if it is let's say 12 noon, okay, so 12 noon, when there is a 12 noon at Greenwich, with respect to the Greenwich, we are 5.5 hours ahead. Okay, so we will be having 12 plus 530. So that is 1730. So right now, if we are talking about what is the time, 530. So right now in London, it would be noon. Okay, the sun will be overhead, whereas we are having seeing the sun setting in our skies over here. Okay, that's how we know the time. So with wherever these lines are intersecting, the longitudinal lines and the latitude lines with respect to that particular location, that we need to communicate to the ATC. So we need to tell, like for example, I am trying to fly a drone at my location in Mumbai. So I need to tell the latitude and longitude of my locations. So I can always check on online or on the mobile also what is the exact latitude and longitude of my particular location. Roughly our Mumbai is 18 or 19 degree and longitude is 72 degree. Okay, so that is how it is. So like for example, if you ask what is the latitude of Delhi, so Delhi is roughly around 30 degrees. If you go to Ukraine, Ukraine is 45 degree. If you go to Moscow, it is 55 degree. As you climb up and you go to the North Pole, it will be 90 degree of your latitude. Okay. Similarly, your longitude will be with respect to the prime meridian, whatever is your degree, left or right, or east or west side. That is how it is. Latitude and longitude have been defined over here.
So longitude is north to east. I mean, north to south.
So, Nishan,
Can you hear me?
can you please
Hello.
go ahead? I have,
Longitude lines are north to south. Correct.
sorry, longitude lines are
North to south.
North to south. Yes, they flow from north to south. So they
Okay.
are, yeah, they are vertical lines.
Okay. Okay.
Whereas your latitude lines are parallel to your equator lines. Okay, so they are
Correct.
parallel and they are horizontal lines on the sphere.
So what is prime meridian per se?
Prime meridian, see, basically somewhere we have to, like how we have a equator as a zero,
Hmm.
right? You have defined a zero, right, somewhere, okay, with respect to the
Correct.
motion of the sun. Whereas you have to define a line on the Earth's surface which says could be a start of your time. Okay, so there has to be some start. How do you actually synchronize the clock? There has to be some baseline to be defined, right? So prime meridian is a baseline for you defining your time. Okay, so
Okay.
this was actually, so you could have defined any given point in time, any line on the earth as a prime meridian line. But since in olden days, when the UK, Spanish, Portugal, French, all these people were actually becoming a seafarer and they were going into the sea and they want their clocks to be synchronized for a time synchronization and time uniformity. uh, London, UK being as a primarily that point in time was on the top of the world and they were ruling most of the countries in on the earth. They took the chance and they decided that the Greenwich location, there is an observatory in Greenwich which keeps the time. And with respect to the Greenwich, everybody has accepted that as a prime meridian location. So that line, what crosses the Greenwich line, is a prime meridian. And with respect to that, the left and right side are the time zones. What we do. So
Okay.
like how we say, like Dubai is 2 hours after us, or Singapore is 2.5 hours ahead of us, like that. So based on these longitudinal lines, the time has been defined. Okay.
Okay. Okay. Yeah.
So let's see now what are the RT frequency spectrum over here. So RT frequency, if you see, it is a spectrum. Okay, if you see down, the increasing wavelength. Here your wavelength is like 100 kilometers, 10 kilometers, 1 kilometer. So your wavelength always increases on your left side. Whereas on the right side, you will always see the frequency, increase in the frequency. Like here you have a higher wavelength, but your frequency is very, very low, like 3 kilohertz. Okay, 100 kilometer wave. So these are very uh, bigger wavelength, but shorter frequencies. Whereas as you move on the right side, you will see your wavelength is decreasing. You have a smaller wavelength, 10 meter, 1 meter, 10 centimeter, 1 centimeter, 1 millimeter. That means what? Your frequency is smaller. Okay, your sorry, wavelength is smaller, but your frequency is high. So if you see from below scale, 3 kilohertz, when your wavelength is shorter, your frequency is very high. So for 1 of wavelength, your frequency is about 300 gigahertz. So on this different frequency, different instrument will communicate. So where your wavelength is high but frequency is low, this is basically used in maritime radio. I think Gautam can tell you more about this because he is from the merchant navy. They might be using it on regular basis about this. Gautam, you want to add something on this?
Yeah, VHF we normally use for close range, 30, 40 miles, and HF is used for a higher range, few hundred kilometers.
Correct, correct, correct. So you see, increasing the wavelength, shorter the frequency, but as you move away from this location, but now see this earlier, this maritime radio navigation or maritime radio, these are very basic type of communication. Right now, we are having a better communication facility and coverage because of the satellite technology. That is what right now Gautam said that we are mostly communicating on VHF and UHF. So right now, most of our communication is happening around VHF and UHF spectrum only. Okay, right? Whether it could be a television, FM radio, UHF television, mobile phones, GPS, Wi-Fi, 4G, 5G, all these things are happening within this frequency range. This was in olden times, which was majority used, or this is some like I would say this is a second or a third level time of communication. Like if all of this technology fails, we can always use. I mean, you can see in the ships there are instruments which are available so that you can communicate on these frequencies also. In case of any kind of emergency or in case of this kind of technology fails, you always have this older technology also available in ships and as well as in radio navigation purposes also. Like how we use ham radios also. Like ham radio is the last option where all the communication could fail. We can still communicate with each other in the world in using the ham radio. Okay, so same thing goes for VHF and UHF. So basically, our drone will be communicating between UHSF and HSF frequency, because your drone, when it is communicating, the RC is communicating with the drone. It is communicating at 2.4 gigahertz. So it is communicating on UHSF. It is communicating with GPS. It is communicating with Wi-Fi. It is communicating on 4G. Whatever the drone is using technology, there are drones which are using GPS, there are drones which are using Wi-Fi, there are drones which are been developed using 4G and 5G technology also. So they are primarily using in this spectrum of band. Similarly, on higher side, like your drone is also equipped with video camera. Okay, first person view cameras are there on the drones, which gives you the video footages of your drone getting flown. Okay, so that first person view is been transmitted on SHF frequency, that is 5 gigahertz. Okay, 5 or 5.5 gigahertz, on which the communication is happening. So your range of drone communication is happening around this. On primarily right now, all the communication, whatever we even in ATC technology also we are using this communication, VHF, UHF, and SHF. And higher frequency, like if you want to communicate with the satellites, or you're communicating over the satellite phones, you use extra high frequencies. Okay, so that is basically a radio astronomy, satellite communications, all that things are happening at this. So where your wavelength is shorter but your frequency is very very high. So your wavelength is just small 1 mm. Okay, 1 mm shorter frequencies, but your frequency is very very high. Here what happens, though the wavelength is small, you need a lot of power to transmit the information. Okay, whereas if you see on this side your wavelength is very very big. So you have a very big wave. Okay, so in one big wave, you don't require much power. Even a small cell battery can transmit your signal on VLF or LF mode also, or even MF mode. That's why in olden times we used to hear the radios on batteries. Like if you put a battery, your radio can be working for more than a week or 10 days, or even sometimes in a months also. You don't need to change the battery because they don't use more power, because this frequency doesn't require much power. They use on a mid frequency or only high frequency up to that level. But whereas wherever you have a frequency, a higher frequency and a shorter wavelength, you need more power to be transmitted. That's why you see television, you need to cover to a power source. Mobile, you need to keep on charging regularly. Okay, because they are consuming every time it is trying to communicate or it is trying to send signal over the high frequency lines or shorter wavelengths. Okay, so any questions on the frequency spectrum?
Nothing for me.
Okay.
Nothing.
So this is the second last slide, I would say, about the RT phraseology. When we talk to ATC, we need to communicate to them in a proper manner. Okay, so this is the terminology what we use, or of RT phraseology what we call. So whenever we are reporting to ATC, we have to first say the word called unmanned. Okay, you have to say unmanned. So moment you say unmanned, the ATC will know that you are talking about drone operations. Then you have to communicate the unmanned with UIN number. So you will talk about UIN number. It could be ABC 123 XYZ, whatever the UIN number is there of the drone, that you need to communicate. So the ATC will know that you are talking about unmanned operations and you are providing the UIN number. So Gautam, you asked about the call sign. Here there is no call sign, but you are communicating with respect to your drone UIN number. Okay,
Okay.
so which drone you are communicating or which drone you are going to fly. So similarly, like how you have when you are talking to ATC for the manned aircraft, you normally always tell about your aircraft sign, right? So Victor, Tango, Alpha, Bravo, Charlie, whatever that name is there, that you normally communicate with the ATC. Similarly, here you are talking with unmanned, and then you are communicating about your UIN number. Then you will communicate about your latitude, longitude, and the radius of operation. It could be like XYZ. Like if I want to operate in Mumbai location, like I would say 18 degree and 72-degree longitude, and radius could be my 3 kilometer range. Okay, and then altitude, it could be since I would be talking to ATC, it will be above 400 feet, and it could be, let's say, 2000 feet of my operations, whatever base to ceiling, whatever operations I'm going to do, that I need to communicate. And what is my start time of my operations? It could be 10 a.m. or 11 a.m., whatever time, and what is the end time? Okay, it could be a 30-minute operation, it could be 1 hour operation, it could be a 2 hour operation. So that way I will communicate. This communication, first time communication, will happen prior to the actual operation time. So let's say my operation was scheduled at 10 a.m. I will communicate to ATC at least 8 a.m. Okay, 7 a.m. or 8 a.m. and make sure that aware that this operation is going to conduct. However, during the operation also, before commencing the operation, you need to again communicate to ATC that you are starting your operations. Okay, so remote pilot should prefix RPA call sign with the word unmanned. So what is RPA call sign? Your RPA call sign is nothing but your UIN number. Whenever it is required to have a voice communication with ATC, operator needs to inform the ATC with exact latitude, longitude, radius along with the altitude, that is height to base to ceiling. The radio phraseology is to be used both ways, alphabetic as well as numbers. Okay, so as I said, we can't use our own Indian radio phraseology. Okay, like A for alpha, B for ball, and like D for Delhi kind of thing. We have to use actual RT phraseology which is used in aviation world. ATC frequency are to be monitored only on listen only mode. Communication is to be maintained via line line. Since you are not a licensed operator, you cannot use ATC frequency on the devices. You cannot communicate on those devices, like the modes, the radio modes, whatever there are, the radio devices, what can be used by authorized persons. The radio communication on airband frequency is only allowed for the operator who is certified to operate the wireless RT equipment with a valid RTR or FTRL issued by WPC or DGCA respectively. So if you have the license to operate those devices, RT equipments, then only you can use it. If you are not, then you have to communicate only on landline. For example, when we were operating operations from Dhule Airport, since Dhule Airport was a proper airport, we had people over there who can communicate with the ATC over the RT equipments also. Whereas in Igatpuri we do not have anything facility like that. Okay, it's just a purely a simple base flying base for drone only. So we would have to communicate only through landline in case we are intend to do any operations in yellow zone over there. Like for example, if I want to fly, though I am my flying base is in green zone, but the moment I cross the 400 feet, I will be in a yellow zone also. So if I have to fly above 400 feet, that point in time, I have to communicate to ATC with that phraseology. Okay, unmanned, UN number, latitude, longitude, radius, altitude, and start time and end time. Okay, that's how we will communicate. A standard phraseology is used throughout the globe with minor difference with respect to the different regions. So whatever those alphabets, whatever I said, A for alpha, B for Bravo, that is a standard phraseology which is used globally. So you should use that only. Nothing else you should use. There could be a minor differences, like there might be a slight one or two words here and there are different with respect to region. Probably like Argentina, Brazil, they use little bit different, or even Canada people use some words differently with respect to the phraseology. But more or less 99% all uses the same standard phraseology across globe. Okay, so planning procedures. Yeah, Priyank.
Just to clarify, could you go back to the previous slide? So here we are talking about communicating to the ATC, but you also mentioned that you need to be having, uh, like you need to be certified to operate
in case
wireless radio
in
transmission.
case yeah in case you have a wireless RT equipment, if you are certified,
Okay.
then only you can use the equipment. If you are not certified, you cannot use RT equipment. You can only communicate with ATC on the landline.
Okay. So is that an option? Like we can get ourselves RT certified?
Yes.
Okay.
That's what I said on 3rd February 2025. DGCA has released the new norms for RT exams.
Okay.
Okay, so shortly, currently it is being managed by WPC. It will be coming over under the DGCA by June or July. So once the
Okay.
DGCA is completely control of RTR, this thing, they will start conducting regularly the certification. Currently, the certification is being carried out by WPC department.
Okay.
Okay, flight planning procedures. So whenever you are planning these procedures, okay, in case of you are planning any operations in yellow or red zone, you need to apply these applications on flight planning on digital sky platform as necessary. All landing zones and emergency landing zones should be pre-planned before takeoff. So you should be defining what is your landing zones and what is your emergency landing zones in the respective area of your operations. In case of any planning you have doing it, wherever you required FIC, that is Flight Information Center, confirms about the flight plan, and ADC stands for Air Defense Clearance, a security clearance needed before entering the certain airspace. See, basically these terminologies are more from the aviation perspective. Whenever I am putting a flight plan for, let's say I want to fly between, uh, let's say Mumbai to Dubai. Okay, so in that respect to that, or probably let's say take a simple example, I'm flying from Mumbai to Delhi. So in that scenario, I need to file my flight planning prior to my operations, almost 24 hours prior. Okay, and it has to be get approved. Then only as a pilot, I am authorized to take that flight. Okay, so all flight routes should be predefined. Okay, all your flight routes should be predefined. It should be planned. You cannot just take go and go and fly your aeroplane. So you need to have your flight plan needs to be approved with the ATC, and all the respective approvals needs to be taken. Even though you are a pilot on a regular daily basis, you are flying on that route. Maximum time you would have seen a lot of pilots fly on a same route for 6 months to 1 year period. Okay, after a period of 6 months to 1 month, 1 year, only their routes are being changed. Okay, their routes are not frequently changed. They are only changed after a given period time. Even whenever their routes are changed, they are not given a primary role initially. They would be always in second in line. The primary role will be always on to the person who is regularly flying on that route. So you will be second in command. Maybe you will be flying the aeroplane as a second in command on a written path or one side path. The captain might say, okay, now you fly. I will monitor and help you. In that scenario, how you will be able to learn over there. Okay, so anytime, given point in time, as a pilot, as a primary pilot, your flight planning has to be done. All landing zones, emergency landing zones should be pre-planned before takeoff. FIC, ADC, like wherever. Like for example, if you are coming from international boundaries, you have to take the flight information center permissions as well as ADC, that is air defense clearance. If I'm crossing the international boundaries, also like if my aeroplane is coming from UK to Mumbai, so it has to enter the Indian airspace. So it has to take the air defense clearance also for that. So there is a lot of procedures which needs to be followed and taken. So this is all automated procedures online, and then they file it and they get it approved prior. That is 24 hours prior. Okay, the same thing is applicable for your operations when you are doing in red zone or yellow zone. You cannot just simply wake up and start say I will fly in yellow zone. Okay, that you can do in your green zone, but not in yellow zone or red zone. You need to take all prior permissions, approvals, and then only you can do your operations in those zones. Clear? Okay. Okay. So this is um, basically with respect to the operations, because we talked about the altitude. Okay, we need to communicate to ATC about the altitude. So whenever we are communicating operations of our drone, earlier also I informed you that most of the time our drone operations is with respect to the terrain. So here we will be always communicating with respect to QFE. Okay, QFE is nothing but field elevation. Okay, in a nautical terminology, it is called QFE is field elevation or height. Okay, and this is measured with respect to the Earth surface with respect to the runway. So if I am standing on Mumbai airport, I will talk about when my drone is on the ground. it will be reading altitude as 0 degree, sorry, 0 feet or 0 meters. Okay, whatever the unit I am using. So with respect to the ground, my drone when it is on ground at the airport, it will be 0 feet or 0 meters. Moment I take it off, let's go 10 feet high or whatever 20 feet high, I will communicate to the ATC that my drone operation is at QFE of 20 feet or 200 feet. So whenever I say QFE 20 feet or 200 feet, it is always with respect to the ground. Okay, but assume that aeroplane you are flying or you are flying a drone which is nearer to the sea, okay, at the sea level, like in Mumbai we are very close to the sea, okay, near to the sea level. So that point in time, if I want to communicate to the ATC and I want to communicate with respect to QNH is with respect to the mean sea level. Okay, mean sea level is calculated based on last 20 years of data. Okay, what is the highest tide and what is the lowest tide? Based on that, that location mean sea level is being calculated. With respect to the mean sea level, you will always communicate your nautical height. Okay, and if you are in middle of the sea, okay, in middle of the sea, how do you will know the height? Because there is no mean sea level over there. There is no reference point to calculate the mean sea level in the middle of the sea. How you will calculate the height of the aeroplane? There you will calculate with respect to the standard atmosphere level. Okay, your standard atmospheric level is 1013.2 hectopascal. So with respect to that standard atmospheric setting, whatever your altimeter is showing, that time you will say in my nautical elevation or my field elevation, what we call, okay, field elevation is basically XYZ, whatever the 200 feet or 2000 feet or 20,000 feet, whatever is there, that you will communicate. As of now, don't worry about QNE and QNH. You just leave them aside. What is more important from a drone operation is QFE, because that is with respect to the earth surface or with respect to the ground. Okay, not necessarily every time you will be doing with respect to your ground. Even on our on our authorized field, our ground is 0 degree. Okay, zero altitude, 0 feet altitude or 0 meter altitude. So whenever I am flying my drone with respect to that ground, whatever my height is there, my QFE or field elevation will be defined as my height of the operations or altitude of my operations. Okay. Any questions so far? Yeah, Nishan.
सर इसमें एक्यूरेसी कैसे रहेगा? How can we consider the,
Accuracy with बहुत respect.
for example, our ground which is there at Igatpuri, it is already a hilly region, na?
Uh-huh.
So how can we consider it as 0 degrees?
See, with respect to that ground, okay, for example, let's say take example, forget about Igatpuri. Take example of Mumbai Airport. Now, Mumbai Airport is at elevation from the mean sea level is 8 meters. Okay, so forget as of now that 8 meters. Let's take the airport runway is as a 0 degree. So with respect to that runway, how much height is my aeroplane? So when I am communicating to ATC, I am saying my QFE is let's say 20 feet. So my ATC will know with respect to the runway, the aeroplane is at 20 feet height from the ground as of now. But the same altitude he needs to communicate with QNH. Now QNH is what? The difference from the mean sea level to the altitude of the runway, so which is 8 meter. So that 8 meter plus QFE, that is 20 feet. So that is 28 feet altitude. Okay, so when I am communicating QNH, I will be communicating it as 28 feet. Whereas you will not communicate on ground about your altitude or height. Only standard altimeter setting will be used when you are in sea. Okay, where there is no reference point. Okay, so there you are setting your altimeter to standard atmospheric settings. Okay, so it will with respect to the standard atmospheric, whatever the reading you are getting on the altimeter, you will say with respect to my standard altimeter setting, that is QNE, my current altitude is 20,000 feet. Okay, so ATC will know that with respect to what you are actually communicating your height. Okay, whether you are setting with the standard altimeter setting or standard altitude, which is a local altimeter with respect to the mean sea level, or height above the ground. Okay, so I think next
So sir,
slide.
let's say there is another aircraft near my aircraft, okay? which is at the sea level, so QNE level.
Hmm.
So the difference between QNE, QNH, and QFE will be known by the ATC, right?
Correct, correct. They
Ah,
are aware, no? They will be
correct.
aware the differences. See, why?
Okay.
Because see, there could be an aircraft which is flying near the sea, okay, near the sea, and it is approaching the land. So that time he will communicate with QNH. So ATC will know that when he is telling my altitude. See, these words are makes difference. Altitude, okay, or QFE, which is called as in weather and meteorology. There is one more slide on this topic. Okay, so this is called as field elevation. Okay, this is called as nautical height. Okay, this is called as what we say standard altimeter setting. Okay, so these three different settings will tell you about the difference in the communicating what height you are communicating with reference to what. So when I am saying QFE is very clear. It is near to the runway, very clear to the ground. Okay, so with respect to the whatever ground you are referring, that height you are mentioning. So they know. See here, they know that QFE indicates zero altitude at the airport. So for example, if I am flying a drone at my base at Igatpuri, so my base at the ground will be 0 degree. It is taken as that as a base. Okay, from there it is calculated height. So the my altimeter automatically will be set at 0. So when you see on your panel on your remote control, when your drone is on ground, it will be showing 0. Okay, the moment it takes off in the air, it will start calculating. So it is there is a basically a terrain radar is there. Okay, there is a terrain radar which is sending a signal from the ground, and it will be detecting its height. Okay, and that height it will be calculating. So don't worry about, even though there is a difference. For example, the location where I am flying and maybe a 100 meter away, that location may be a difference of 2 meters. Okay, so I will tell you, I will just remind me during the flying time, this same thing. I will explain you much more in detail, because my ground was actually three-layer ground. There was a variation by 2 meters in the ground, and how our drone was flying and how our drone, like for example, there was a shape like this. Then the ground was little bit down. Then the ground was little bit down. So moment I set my altitude for 10 minutes, 10 feet lock. So as I vertically fly my sorry as I flow my drone horizontally, जैसे ही वो higher ground पे आता था ना, my drone used to gain the height. So people used to think why drone is going up. No, the drone is not going up. It is trying to set its altitude fixed, because with that surface, the altitude should be 10 feet. Okay, so it is trying to raise the ground by setting the 10 feet altitude. The moment I bring it again back to the original location, again my drone used to come down. So it is to set that height. Okay, so it is always with respect to the ground. So there is a terrain radar which is being set on the drone. Below the drone, there is a radar, okay, which keeps on sending the signal, hitting the ground, and it measures the height continuously. So if you have set a 10 feet height, it will be always at that height. The moment you cross the altitude, I mean the height or the ground is little bit. So that's why you will see there will be a stones also. There will be stones, bigger stones also. So a lot of time there will be a little bit variance, okay, by centimeters also sometimes, because of the response, the signal which ultrasonic signals which goes down and comes up, it will have little bit variance in the vertical sensing also.
Sir, in planes,
Yeah,
in passenger aircrafts, there is no incline. They maintain 30,000 or 35,000, whatever the altitude is, which
correct.
means they use the QNE.
QNE is used only on the sea.
So, sir, how they maintain 33,000 or 35,000? They don't go any incline or descent is not there when the flight is
Right. So,
constant, right?
for example, if I am flying from Mumbai to, let's say, Delhi, okay, so when that is completely a path, if I'm not using the sea, even I am closing to the sea, okay, mostly like if you see I am flying from Mumbai, I'll be flying very close to the sea level. So, maximum I will be using QFE during my inclined position or flying takeoff position. But moment I am on a flight, I will be using QNH. Okay, but the moment enter the land, okay, that is my, let's say, Gujarat. Okay, from Gujarat onwards, everything is land. There is no sea. So that point in time, always I will be use QFE, because with respect to the ground, I am measuring it. But let's say I am going from Mumbai to Dubai. So what will happen? My flight will take off. I will start with QFE. I will at point in time I will be using QNH when I am just about to enter the sea or just cross the sea. At a point in time I will be in a deep sea. There is no reference point for a ground or mean sea level. I am in a deep sea, so I have to communicate with respect to QNE. As I reached Muscat, Muscat is the point where I will start entering the land space. So I will again use QNH, and I reach closer to the Dubai, I may use QFE. So over the period of your flight, you have to different. That's why these different terminologies are there. So when you are at what point in location, what is your altimeter is being set, whether it is able to set for QFE, QNH or QNE. Based on that, you have to communicate to them. And it is not that there are one altimeter is there. There are at least three altimeters are there in commercial flights. So all three needs to be set into the same readings, and you need to follow and see that all are showing the same readings. If any given point in time, any is there is a missing, there is some wrong in that. Okay, so that's why there are three. There are three. Why? Because two pilots will have their two, and one is common for both. Okay, that's why there are three altimeters in cockpit at any given point in time.
Got it.
Okay, so again you can see here QFE is the height. Okay, so this is height. Again, I gave the example of elevation from the surface. Like assume this is a Mumbai airport, and you have an elevation of 8 meters. So your QNH with respect to the mean sea level. Okay, so your altitude is nothing but height plus elevation, whereas your flight is nothing but with respect to the standard atmospheric pressure. Where you will measure the standard atmospheric pressure? In the deep sea. You are crossing Atlantic Ocean, you are crossing Pacific Oceans, you are crossing Indian Oceans, where there is no reference point. So there you need to have some reference. So you will take with reference to the standard atmospheric pressure. Okay. So standard atmospheric pressure at the mean sea level is 1013.25. Okay, with respect to that, it will measure. So it is a basically a barometer. Okay, barometer which tells you the height. Okay, barometer will tell you the height. Okay, so pressure when set to a pressure of 100, you may use to indicate flight level. So when I am saying QNE, that means I am talking about my flight level. When I am saying QFE, that means I am talking about height or field elevation. When I am talking about QNH, that is nautical height, that is the time I am talking about altitude. Okay, so my altitude is nothing but height plus elevation. Okay, as of now, don't worry about. I will be sending one more picture which will give you more clarity about these things. And remember, when in a drone operation, we are always communicating about QFE. Okay, that is the height. And your drone, when it is on the ground, it will be reading what altitude or what height. When it is on the ground, zero.
QFE
Right. QFE will be 0. Okay,
0.
so that is what here it is saying. At airport altimeter datum, and altimeter set for QFE indicates 0 altitude, meaning on the airport the altimeter will read 0 fade. Okay, so remember this. This is very important with respect to the drone operations. Okay, so with that we complete uh, the ATC procedure and telephony. I think we have already crossed 6 o'clock, so I think we should. We are a little bit behind our schedule, but no worries. We will be completing within the timelines. Uh, we will be stopping here today. If you have any questions to discuss, we can discuss, or we can wind up.